payloads in Germany. From Germany, I work in Belgium for Space Application Services. I'm here as representative of the Space Generation Advisory Council. I'm the lead of the Nearest Objects project group. And for those of you who have not heard about us yet, we're an international NGO aimed for students and young professionals from all over the world. We're headquartered in Vienna and have an observer seat with UN Corpus. We try to give, we're also a professional network for the students and young professionals, and we are providing the perspective of the youth to the United Nations, space agencies and other organizations. And the SGAC, in short, has several year-round working groups. One of those is the one on nearest objects. And we're helping the planetary defense community to tackle one of nature's greatest challenges, which is the threat of asteroid impacts. We do this by competitions and outreach events like this one. Before we start, I would like to thank the IAF for giving us the opportunity to talk about NEOs and planetary defense today. And I would like to start by introducing our panel today. We have Dr. Scott Hubbard. He is a professor at Stanford University, where he focuses on planetary exploration, especially Mars. He worked for 20 years at NASA and received the highest award, the Distinguished Service Medal. He also works for the B612 Foundation and is a program architect for the Central Mission, about which he will tell us a little bit later. We also have Dr. Dorin Prunario. He is Romania's first cosmonaut. In 1981, he completed an 8-day mission on board Soyuz 40 and Salyut 6. He was elected chairman of the UN Corpus. That stands, by the way, for those who are not familiar with these terms, for the United Nations Committee on the Committee on the Peaceful Uses of Outer Space, from 2010 to 2012, and he was elected president in 2011 of the Association of Space Explorers for a term of 3 years. We have with us Dr. Sergio Camacho. He is the chairman of Action Team 14 on nearest objects at UN Corpus. He's currently the Secretary General of the Regional Center for Space Science and Technology Education for Latin America and the Caribbean. And previously he was the director of the United Nations Office for Outer Space Affairs. Also we have Dr. Ray Williamson. He is the senior advisor and former executive director of the Secure World Foundation, a private operating foundation with headquarters in Colorado. Ray is also an external faculty member of the ISU and teaching general space policy. Further, we had some contributions today in form of slides and input from the Minor Planet Center, the Planetary Society, the Aerospace Corporation, and Debbie Lewis, who works for Axiom Alderney. Okay, this one looks a bit better. Can you still hear me? Okay. So, let's start with the basics for those who are not familiar. What are NEOs? They're near-Earth objects, so asteroids or comets that come close to the Earth at some point in the orbit and thus present a potential threat. How close? A general consensus is closer than 0.3 astronomical units. That's about 45 million kilometers. You can see two pictures of one smaller one. Well, it's still relatively large. Of asteroid Itokawa on the lower left, and a bigger one, asteroid Ida, which even has its own moon. You can see as a which is still very large. It was more than 1 kilometer in diameter on the right. Here you have an overview of all the asteroids that have been visited by spacecraft to date. The biggest one is Lutetia. That was a flyby by Rosetta a year or two ago. And the other ones, you can see the actual size comparison with the other asteroids. What is planetary defense? Simply put, it is protecting Earth from asteroids. This includes what we know about the threat that is there from asteroids and comets, what consequences an impact could have. It deals with techniques for deflection, also deflection of mission design, disaster mitigation, and of course, that might be the biggest problem actually, political and policy and legal issues associated with such missions. You can see in the lower left, that's a meteor crater in Arizona as an example of a meteor crater on Earth. And on the right, you see all the red dots that are the locations of known craters up to date. I mentioned the threat. What threat is there? Well, there are different types of asteroids, mostly well, related to their size. We have smaller objects that break up in the atmosphere, and we will later see an example of that. We have Tunguska-like events. Tunguska, it's a region in Siberia where in 1908 a 30 to 50 meter object exploded in the air and leveled 2,000 square kilometers of forest. That's about the size of the surface area of New York City. So if that would have hit over a city, we would have a lot more than just 2 casualties that resulted from this one. So, and this happens roughly every 250 years. That doesn't mean it's really frequent. It can happen tomorrow, it can be in 500 years, but that's just an average. So don't lose any sleep yet, but keep it in mind. We have a threshold of, there are the different sizes. Obviously, the larger ones are rarer than the smaller ones, which happen more frequently. But the bigger ones make more damage, so we can be limited to regional effects or even global catastrophes like the one that wiped out the dinosaurs. How many are there? Here is a recent updated chart that was updated after the WISE mission, which discovered several new asteroids and helped us refine the numbers a bit. You see in this chart the different sizes, and in blue you see what was estimated before this mission, and in green what is the new estimated population. The ones that are still empty are the ones we have not discovered yet. So we know they're there, but we don't know where exactly, which obviously is not helpful in knowing if they're coming our way or not. Here you have some numbers. The known near-Earth asteroids are, I checked the numbers yesterday, they're currently 10,125. And you see on the picture on the right, you have a plot of the inner solar system with Sun in the middle, and the 4 circles are the orbits of the 4 inner planets. The green dots are the asteroids in the asteroid belt located between Mars and Jupiter. And all the red ones are the ones that crosses Earth orbit at one point in time. So the red ones are the ones we need to watch out for. We know about 6,000 of them are larger than 100 meters, so they can make considerable damage. We expect of them, based on the chart we saw before, that around 20,500 of those exist, which means so far we only found about 30% of them. Obviously, astronomers are looking, and on average per night we discover 2 to 3 new objects, and the rate is expected to double by 2015 due to improvements to current servers, and Scott will talk later about how to improve that number even more. Here's an animated graph where you can see how that looks like in the moving environment. I'm not sure if you see the red dots. I think they're very weak. They're there? Okay. This is a ride with Earth for the year 2007, 2008. Earth is the blue dot in the middle, and you can see all the objects whizzing by that are crossing our orbit. So you can see it's quite busy, and it's rather surprising that we don't get hit more in a sense. But space is big, so but you see it is quite busy there. And because it is so busy, astronomers are looking and they're finding things. For example, 2012 DR14. It was discovered in February 2012. It was estimated to be about 44 meters across after the would make its closest approach on February 15, so just 1 year after discovery, very close to Earth, within the geosynchronous satellite belt. So this was the prediction. You can see how the flight path is bended by Earth's gravity. The closest approach was 27,700 kilometers, so that's not far away if you think about it in cosmic distances. It weighs about 40 metric tons and was estimated to be 44 meters across, and during the flyby it was refined to just a 30-meter object. So while the Earth and the astronomers and scientists of the Earth were getting ready for this event, several organizations had live webcasts like the Planetary Society to follow this event live. Nature decided to bring us some breaking news from Russia. So just 16 hours before, we got these pictures, which you might have seen some of those before. What we see here is an object that is entering Earth's atmosphere and breaking up in an airburst. And I'm not sure why this is. Okay. Different perspective. We were lucky it happened in Russia, so we all have this video footage from their cameras in their cars. So you can see the smoke trail and the bigger bulge in the middle. That is where the explosion took place. I'll skip that a bit. So later analysis showed it was an object about 17 to 20 meters across, weighing about 10,000 tons. It entered Earth's atmosphere with 18.6 kilometers per second. That's 67,000 kilometers per hour, so that's quite fast. The airburst happened in an altitude of 23 kilometers and produced an explosion of 440 kilotons. What is most surprising to most people is the fact that the object was not detected before it enters the atmosphere. It was shown that it was unrelated to the expected flyby of DR14, so there were two different objects. And it came from the direction of the sun. That's our blind eye, if you will, because we have to look away from the sun to detect asteroids at the moment. So, so clearly there was a wake-up call for Earth, as the damage would have been a lot worse if the object had been bigger or the entrance angle steeper than it had. About 1,500 people got injured in this. Luckily, nobody got killed, and I will show you where the injuries came from.
И сгорел там, да? А что думаешь, может спутник там? Уже же падал, они...
Work ahead of us, and I'll hand it over to Scott now to talk about a bit more how we detect asteroids.
Thanks very much to Alex for framing the problem so dramatically. I think we can all agree that there is a threat here, and the thing that's different about this type of natural disaster is that this is a completely preventable threat. We don't know when earthquakes might happen. Predicting the course of hurricanes and typhoons is complex. But if we have the right tool out in a Venus trailing orbit or a Venus-like orbit, we have the ability to detect these objects, certainly those larger than 50 meters or so. Once we can detect them, we can deflect them. There's been a great deal of discussion over the years about deflection, but as my colleagues Rusty Schweikert from the Apollo 9 mission and Ed Lu from the shuttle and space station, spending 6 months on the space station, who are my colleagues in this effort, would point out, if you can't find them, you can't do anything about it. So about 2 years ago now, Ed Lu, who I'd known since his shuttle and space station days, called me up at Stanford and said, I have an idea I want to discuss with you. Would you have lunch? And of course, we live in Silicon Valley in California, and that's the way everything starts. Let's do lunch together. So he said to me, you know about the near-Earth object issue? And I said, yes. A long-time colleague with somebody who occasionally goes by the name of Dr. Doom, whose name is Dave Morrison. And you saw Clark Chapman and Morrison cited earlier. Dave is a really deep expert in near-Earth objects, and so I've known about the issue for a long time. And what Ed said was, we would really like to focus not on deflection, but on detection. And we have an idea for a space-based telescope, and we'd like you to work with us on defining a program that would carry this out. And, like many of us, we spent a lot of years with a government agency, in this case NASA. He said, but if you were to do it any way you wanted to, not having to depend on NASA funding, and in the most cost-efficient and effective way, what would you do? And I described the approach I would take, and he said, that's great. Well, why don't we go do it? And so I agreed there on the spot to be part of the B612 Foundation, and particularly the Sentinel mission. And Ed said to me, now come up with a name for yourself that doesn't sound like NASA. And I said, okay, how about program architect? So instead of building a house, I'm architecting a whole mission and all the piece parts that go with that. And what I'll do in the next 10 minutes or so is describe the spacecraft approach, the detection approach, and some of the unusual features. We plan and are in the midst of funding this totally through philanthropic means. This is unusual for a program of this size, but I'll give you some analogies and tell you why we think we'll be successful. So this frames the problem, only in a different way. This is an American football stadium, so you see Chelyabinsk and you see Tunguska and as Alex pointed out, either one of these hitting in a populated area would be a true tragedy and a major disaster. Of the near-Earth objects that are in the 50-meter or so range, we know perhaps only 1% of those. Now, Alex gave you some numbers, and all these depend on where you draw the threshold line. So if you draw the threshold at sort of a 50-meter level, there could be upwards current projections that are model dependent, but the current projections are perhaps as many as 1 million objects, near-Earth objects out there in that range and up, 50 meters and up. And currently we know 10,000 or so of those, so there are a lot more that need to be found. The way to find them is by going into space. These objects are very dark, and the only way you can find them is by looking in the infrared, the region of the spectrum that's just beyond what we can see with our eyes. It's the region that you can detect these because the sun heats them up and they glow. So they're warm if you have the right sort of detector. And the right sort of detector would be something that looks like this. This is a spacecraft that has very high heritage. Now, is there anybody here that's been involved in spacecraft design? A few of you, all right. So the word heritage is fraught with traps. People cite heritage because somebody did a design 30 years ago that was never built. In this case, it has a little more substantial meaning because this spacecraft is a combination of the functions and in some cases the actual as-built design of 2 previous missions. One, the Spitzer mission. Spitzer is an infrared observatory. It's still up there. Its cryogens are gone, the thing that keeps the detectors cold, but it's still operating in a warm mode. So Ball Aerospace built the Spitzer, much of the Spitzer telescope. They also were responsible for building the entire Kepler mission. Kepler is a mission that's near and dear to my heart. I was, in my NASA career, I finished as the director of NASA Ames, and NASA Ames is the home of the Kepler mission and its principal investigator. And this is the one that's found thousands of planets around other stars. So what we've done to create this telescope is to take the best infrared parts of the Spitzer mission and the design for the focal plane array, the detector array from the Kepler mission, and put them together. And so I think the claim that this has a lot of heritage, meaning things that have been built before, is really quite justifiable. So the idea is to launch this aboard a Falcon 9. We're aiming at about 5 years from now, July of 2018, and we would go into an orbit roughly that of Venus, looking out into the solar system with a very wide field of view, 120 degrees. And if you do the calculations with the optics that we've got here, which is a mirror of about 85 centimeters or so, I guess it doesn't say that up there, with the right kind of detector, 50 centimeters, there it is. With the right kind of detectors, we can demonstrate through the models that we can detect well over 90% of all of the near-Earth objects that are 140 meters or larger. Now, why 140 meters? Well, there was a study done by the American National Research Council reporting to the U.S. Congress that said if you want to be sure you find those events that could have a tsunami-like effect, an impact that would create worldwide damage, then you need to be at a detection limit in magnitude and brightness in the infrared of about a certain level, and that translates into about 140 meters in size. So this telescope is built around finding over 90% of all the near-Earth objects 140 meters and larger. With enough observing time, mission here about 6 years or so, you should be able to detect a very high percentage of all the near-Earth objects 50 meters and above. That becomes a statistical process based on observing time. So this is the spacecraft. This is the telescope. It's in a Venus orbit, and it has all the right optics and all the right characteristics to find these objects. But we're not doing it in the regular NASA way of business. This has been on everybody's to-do list, a mission like this, for quite some number of years. But the American agency, NASA, has never been able to come up with the funding for it, because this is not strictly a science mission, nor is it a human exploration mission, so it falls in the cracks from a programmatic point of view. So our team, Ed Liu, Rusty Schweikert, myself, Errol Reitzema, retired from Ball and so forth, decided to take it on. And we're focused on a single project. We got a very small team, but a very, very experienced team. Very stable requirements. The death knell for any project, if you want to keep it in a tight box of cost, is to start changing things. So we've got very stable requirements based on the Kepler and Spitzer telescopes. And this is a very unusual thing. We're doing this through so-called commercial process. We're not doing a typical contract that is an open-ended contract to industry where they work and get paid no matter what happens. We're going to buy this in the same way that you buy communications satellites or remote sensing satellites, like Worldview, Digital Globe, Space Systems Loral, and so forth. And we've worked very closely with Ball on exactly how we would do this. We do have NASA as a minor partner, a junior partner, because the Deep Space Network is the most efficient way of bringing the data down, and they've agreed to do that. So let's talk about fundraising. What is this going to cost? We believe that the spacecraft, using what I described earlier, can be built for about $250 million. And we need probably another 200 or so million for all the operational aspects. That makes $450 million. That's an awful lot of money. Certainly to you and I, unless, I don't know, is Bill Gates in the audience, or, you know, Elon Musk? No, okay, so it's a lot of money to you or I. But just for example, the new de Young Museum in San Francisco, this is a museum of art, cost more than this spacecraft, cost $500 million. Alex McDonald, who's a brand new PhD economist, did a study of all the observatories built actually in the world since actually the 19th century. Up until World War II, science was done privately. It was the advent of World War II that really created big science. If you look back at two observatories in the United States, Mount Wilson Observatory is worth about $630 million. It would have cost about $220 million just to do an exact copy. Mount Palomar, very famous 200-inch reflector, is worth almost $1 billion and would cost about $330 million to reproduce. So our argument is, to the philanthropic community, that we are talking about doing something that is really no different. It's just our observatory is in space, not on the ground. At any given time, there's hundreds of these enterprises going on. So we've put together a team of people that includes technical experts. We've also added fundraising expertise, and we're well on our way to, we think we have a solid technical plan. We're well on our way in the philanthropic fundraising effort, which is turning out to be a bigger challenge than doing the design work. But this is, I think, the tool, the kind of tool we need to find these objects. Once you find them, then you can deflect them. So, Alex, I'll turn it back to you.
The winning paper of our Move an Asteroid technical paper competition, which is held annually since 6 years. And it challenges students and young professionals to come up with innovative ideas related to asteroids, from deflection to detection, and planetary defense-related issues to exploration and resource utilization. This year's edition main sponsor was OHB, And we're very thankful and grateful for their support, as it allows a young person to come here and present their ideas at the Space Innovation Congress, as well as now here at this venue. This year's winner is Massimo Vatrisano from Italy, who is currently a third-year PhD student at the Advanced Concepts Laboratory at the University of Strathclyde in Glasgow. Congratulations, Massimo, and please give him a hand.
Asteroid can cause global major damages, but also the smaller one in the range of tens of meters. So the famous cases of Chelyabinsk and Tunguska. So, but of course, the asteroid could be also a resource. Since if we are able to go there and exploit the resource, grab them, modify their trajectory, we can extract precious raw materials. So, but we need first to approach this trajectory in both cases, this asteroid in both cases, and also the European Space Agency is interested in technological proof of concept to prove the feasibility of in-space application for deflecting a small asteroid in the range of 4 meters. And in a previous study, we proposed to use laser ablation. That is not the topic of this talk. The point is, the problem is that we need to identify the target in orbit and then approach it without missing the visual contact. So the Light Touch Q team was formed, and it was led by my university, University of Strathclyde, in collaboration with GMB and Astrum, and the university in partnership with the University of Southampton. So first of all, going through the target selection, then I will show you the deep space navigation for this mission, and then I will draw the conclusion. So the target selection was done based on the orbital elements, because we need to find an object whose trajectory is close to the Earth, is enough close to the Earth in order to approach it and accomplish the mission in 3 years. Also, we need to have a good knowledge of the orbit, of its orbit. So we based our selection on the orbit condition code, which gives us an idea of the quality of the knowledge of this trajectory. So we selected 2 asteroids with an orbit conditioning code that is below 4. In fact, for objects with an orbit condition code higher than 4, we don't have enough data to predict in a reliable way the trajectory in the 2025 frame. So we consider the propagation of the uncertainty related to the trajectory of these 2 asteroids. And if we consider the first one, we have a very high uncertainty by the time the mission will be performed. It will be in the order of more than 100,000 kilometers. That is well above the accuracy of the current technology. In fact, if we are able to approach the asteroid from the sun direction, we see that with the current technology we can see an object of magnitude of about 30 from a distance of 100,000 kilometers. The second object is indeed has a quite well, the knowledge of this trajectory is quite well known, so we focus on the second target. And in order to design the deep space phases, we look at the past and we reference to the Hayabusa, Rosetta, Near Stardust mission, and we see that this mission relies heavily on optical navigation. And what we have here that we need to combine the approach strategy with a GSC analysis. But in the case of our mission, we have that the asteroid is very small, so we cannot see it very close. For instance, in the case of Hayabusa, the camera was able to see the object from farther than 1 million kilometers. So we can approach, we can detect this asteroid only from roughly 60,000 kilometers. And also we don't know exactly where the asteroid will be, so we need to approach the asteroid very close in order to not miss the target. So we identify essentially 4 main phases for the deep space navigation and approach. The first one is the early encounter, where the rendezvous maneuver is performed. Then will be the far approach and close approach, where the distance will be reduced little by little to less than 1 kilometer. And in this phase, the relative navigation and accuracy related to the knowledge of the asteroid trajectory will be improved from roughly 5,000 kilometers to 1 meter. And then we will have the transition to operation, where majority of calibration and tests we perform in order to have the thrust necessary for the beginning of the operation. So in the early encounter, we need to consider that the uncertainty on the magnitude means that we could see the asteroid in the worst case at only 30,000 kilometers. And then we consider that we of course need to approach the asteroid from an illuminated point of view. So the rendezvous maneuver was performed at 60,000 kilometers, such that after 15 days the spacecraft will be on the plane perpendicular to the Sun-asteroid direction outside the uncertainty region here defined by this circle. And so also the rendezvous maneuver is performed such that after 7 days the spacecraft will see the asteroid with a zero phase angle. So after 7 days we are sure that for sure we will be able to acquire the asteroid. The camera will be able to acquire the asteroid. So in this phase, we have collaboration between the ground station and we use the ground station tracking along with the camera line of sight to improve the trajectory knowledge of the asteroid. And then we perform two trajectory correction maneuver based only on optical navigation, which allows the spacecraft to reduce the uncertainty on the asteroid trajectory from 5,000 to less than 10 kilometers. So then we arrive to the far approach, in which the asteroid will be in the trailing configuration with the spacecraft will be in the trailing configuration with the asteroid, and then we'll perform a small maneuver to approach the asteroid. And in the final phase, we will have the so-called dog-leg maneuver, which allows seeing the asteroid from different perspectives, so to improve the asteroid, the relative navigation. Finally, the spacecraft will arrive on the asteroid sun direction at 1 kilometer. And at this stage, 10 kilometers, sorry. At this stage, the close approach will start. This is here, and this phase is not completely autonomous. It says that at the beginning and at the end of this phase there will be 2 hold points in which the spacecraft will wait for commands from the ground before going to the next phase. And this section will be performed again the so-called dog-leg maneuver through 6 waypoints in which the spacecraft will control the trajectory through a predictive guidance control. At the end, after the second hold point, the hold point, the asteroid will move to 300 meters, where it's also able to use the ranging instrument that is necessary for the operative phase. Finally, we have the transition to operation, where the asteroid will start calibrating the instrumentation, and so it will be able to build trust on the system, the GNC system, which will be used then to operate autonomously the spacecraft at the NEO. And of course, during this phase, the whole meteorology, so the shape and the other estimate on the mass and the inertial properties will be estimated from the camera. So finally, we have proposed a onboard detection small approach based on from the inherited experience from the previous missions, and these allow the spacecraft to detect the asteroid even though the magnitude we don't know many information about it. And then the approach that has been described as reliable, since it's really small, it's really slow, and this is important because we avoid to move the spacecraft in the dark side of the asteroid, so to miss the target. So this strategy can be implemented and used for any other smaller asteroid, but also can be scaled up to bigger asteroid where the surface is very dark, and this way we can navigate the spacecraft, improving the asteroid trajectory. And of course, this method is only applicable to this kind of mission, not for the impactors, where we need a very high relative velocity. And there are still some issues as we have to define a reliable a suitable solution for detecting fake objects in the case we have an uncertainty on the trajectory that is in the order of camera samples. Then of course for actual mission maybe it would be suitable to have very extensive ground station campaign, optical campaign, and radar tracking to the accuracy of the asteroid before. This is to acknowledge all the member of the team and APEX.
Thank you, Massimo. We're a bit short on time, so we keep the questions for later. And I will also skip the next part of my presentation, which would have just been a very brief overview of the deflection techniques that are there, but you can find all the information on the internet release, so just maybe 2 slides summarizing what we can do about them. The deflections is if you do nothing, it will hit Earth. So you have to modify the velocity of the object, so either so it passes before Earth or after Earth in time. So it's basically a velocity change that is needed, so it will pass Earth, and they are slow push and impulsive techniques. But as I said, we'll go right ahead and come to our next panelists. They all share the rough topic, which is related to the non-technical part, so it's more the legal things and how to communicate it to the public behind it. We start with Dorian Pronario, who will tell us a bit about what the Association of Space Explorers is doing in that field.
Well, hello to everybody. I try to make you understand what is the level now of the involvement of the Association of Space Explorers, and not only what we do in respect with near-Earth objects, and why. Well, I will skip some of my slides because some of them they represent general information about asteroids. You already had some of this information. What is an asteroid, what means a near-Earth object, what means near-Earth asteroid. Okay. Where are they in the solar system? You know very well. You know maybe that the last theory about the formation of the moon, it's the theory of the impact. Mars-sized planet impacted the Earth in the beginning of the formation of the solar system, and such way the moon was formed. Representation, a graphical representation of what Carl said just before, how the impact of the Earth and an asteroid happens when they come the same time in the same point. We have to deflect the asteroids to come earlier or later in the point where the Earth passes at a certain time. You already had some information about Tunguska in 1908, when an asteroid with a diameter of approximately 45 meters burned in the atmosphere, and the shock wave flattened 2,000 square kilometers of forest. In October 2008, we had an asteroid in Sudan. Was the first one detected before he entered the atmosphere, but very few time before. And of course the Chelyabinsk asteroid, the very fresh images and information about it. And a few information provided by NASA at the session of the UN COP was about the asteroid in Chelyabinsk. Approximately 17 meters, approximately 6,400, 7,000, oh yes. Wait. 7,700 metric tons. The energy of the impact was 470 kilotons, equivalent of TNT, 3 total when. The altitude of the explosion was at approximately 20 kilometers plus minus 10. Velocity of the impact 18 kilometers per second. Okay, I will pass through. Dimensions and impact frequency of the asteroids. They are very small asteroids, like snowballs. Weekly they fall down on Earth. You have the image of a car in the USA hit by such an asteroid. You have then Tunguska asteroids, like the size of the building. Every 1,000 years, the probability of hitting the Earth is 1,000 years. Bigger ones, like Clipstones, the probability of hitting the Earth is 500,000 years, and very big ones with a diameter of kilometers, 10 kilometers or more, extremely rare, and they may hit the Earth in hundreds of millions of years or billions of years. Okay, what is the possible mortality caused by asteroids? You see here pie with mortality from 20th century catastrophes. You see the biggest one is from war, and the smallest one are for volcanoes, 0.1%, and the same one it's from the asteroids. possible positioning of Apophis in case of Earth impact in April 2029. What we know the orientation of the impact plan, the vertical intersection of the plan with the Earth, and the moment of the potential impact. And we don't know the lateral localization of the asteroid in the plan of impact. It causing quite big problems. You have a graphic with the number of discovered asteroids at this time, in 2013. You see there are about 10,000 asteroids, and large ones about 1,900 and some. And also you have an image of the solar system, and what we can see from Earth. We have a very limited field of view from Earth, observing the asteroids with different telescopes, but radars, and a much larger field of view from mission like Sentinel mission. Scott just told you about this. A graphic showing the energy of the impact of different size asteroids and the probability of hitting the Earth. And you have two examples there, Tunguska 1 and the KT impactor 65 million years ago. Well, now passing to our mission, United Nations and the Association of Space Explorers. Maybe about the United Nations, Sergio Camacho will tell you more because he's the chairman of the AT-14, the Action Team 14 on near-Earth objects. And I'll pass then to the Association of Space Explorers. What we did, in 2005, Rusty Schweikart came with the idea to organize a working group of the Association of Space Explorers. We are now about 370 astronauts and cosmonauts from 35 nations. And to organize this committee to discuss important issues about the asteroids from technical point of view, and not only from social point of view, economical point of view, and so on. Between 2005 and 2008, the work on the issue of NEO was done in the framework of 4 international workshops. And in September 2008, we finalized actually the report named Asteroid Threat, a call for global response. You have the image of the cover of our report. And in February 2009, at the session of the Scientific and Technical Subcommittee of the Committee on the Peaceful Uses of Outer Space, the report was submitted to the UN body, becoming a working document for near-Earth objects. We then organized some other international workshops. One of them was organized by Sergio Camacho in Mexico City in 2010, another one in Darmstadt. You have here the committee established in 2005. On the left side there are the members of the committee, all cosmonauts or astronauts. And we set up a panel on asteroid threat mitigation formed by outstanding specialists in different fields of activity, non-astronaut, not cosmonauts. And you see there are a lot, I don't insist too much on this. Look, a few images from the workshops we organized. The first one was in April 2007 in France, in Strasbourg, at the International Space University. The second one was in Romania in September 2007. You see an image from a working session. The third one was in Costa Rica in April 2008. And the last one, organized with private money by the Association of Space Explorers, was in September 2008 in San Francisco. That's the office of the Google Foundation, where in that time Ed Lu worked. And an image from the meeting in Mexico City in January 2010. What actually the Association of Space Explorers proposed? We propose two types of approaching the near-Earth objects, of the deflection of the near-Earth objects. One, by kinetic impact, pushes the asteroid through a direct impact, or the gravitational tractor pulls the asteroid by using the reciprocal gravitational interaction. You have here a chart of the possible organization of institutional organization to take decisions and to act to solve the problem of the near-Earth objects. For instance, we propose to organize an information analysis and warning network. At the same level, a mission planning and operations group. They interact between them and they report their findings at the mission authorization and oversight group that takes decisions how to act and when is the proper time to act, and then they report, and the final decision, the political decision, is taken by the United Nations Security Council. This is the proposal. Why I said political decision? Because we deflect an asteroid. Maybe the deflection is not successful. We just push a little bit the asteroid to the left or to the right. If the asteroid it's intended to fall down in the middle of the Atlantic Ocean, if we push it to the right, it could fall in Europe or in Russia. If we deflect it a little bit to the left, it may fall down in the United States. What we solve? We cause big problems. So the decision should be taken at the international level by an institution that could have as members as many as possible nations. This is the United Nations. And of course, because the decision should be taken by vote, because not everybody will agree with one or another decision, the only one is the Security Council. Well, what we propose, the functions and responsibilities of the information analysis and warning network are the NEO detection, tracking, cataloging, and impact prediction entities. They are taking part different entities here. You say GPL, NEO-DIS, Minor Planet Center. Then to conduct NEO capability overview, communications based on existing disaster response models, education, risk management, research, and legal implications, establishment and implication of this entity, incorporate lessons learned from disaster management community, search for appropriate institutional model, not allowing too much bureaucracy, because here is no time for bureaucracy. Identify what is needed by the two networks I proposed before, effective feedback and assessment process, and the questions we put and we have to solve, the financing problem, who finance all these things, the structure and longevity of such structures. The Mission Planning and Operations Group workshop from Darmstadt, October 2010, proposed the role of this mission planning group. The role it's connected with information requirements, enabling planning and operations, deflection decision and event timing, evaluate deflection concepts, cost models, and help the mission analysis and oversight group identify operations process. Okay, the findings are that NPOG-like group should be established by space agencies, identify to space agencies the technical issues to be explored for planetary defense, and propose NEO research objectives to guide space agencies, and recognize values of finding hazardous NEOs yearly. Well, what was the status and the timing of the activities? In February 2013, STS Scopus approved the first report of the working group on near-Earth objects, including specific proposals. Sergio will tell you more about this. In June 2013, the full committee approved approved, not approved, the STS-COPOS report, including the working group on inert objects report. And in October 2013, this October, in 1 month from now, the report of COPOS is already submitted to the United Nations General Assembly and hopefully will be approved. Scott just told you about the B612 Sentinel mission. It was done by the members of the Association of Space Explorers, Seth Blue and Rusty Schweikart. As a consequence of the activity we already developed in the framework of the association, and not only. And some conclusions, the Committee on Peaceful Use of Outer Space has come far on neohazard. Global nature of neohazard requires cooperation, and the Association of Space Explorers network of space explorers will continue to assist, educate, communicate and encourage all activities connected with inert objects. Thank you very much.
And Alex said thank you to SGAC for the invitation to make this presentation. What I'm going to try to do is to convey a message that even though there are many actors that have been working on the issue of protecting the Earth in case of a threat of an impact, there has been a great deal of cooperation and coordination. So we're not duplicating, we're actually adding the efforts. And I will do that by trying to cover this in a few minutes. The origin of dealing with the NEOS item in the United Nations is actually the third United Nations Conference on the Exploration and Peaceful Utilization of Outer Space, Unispace 3, which was held in '99. And two other recommendations that were adopted by governments, this global conference, was to deal with NEOS. As a consequence of that, then there will be cover briefly what the action team is. How it was established, a subcommittee and a legal subcommittee. The three bodies work by consensus, which means that if they don't agree, if even one country doesn't agree with something, it is not taken. And this is a very powerful way of working. It's a little bit slow because the issues then carry throughout the years until everybody understands what they're agreeing to and what are the actions consequences. The NEO issue has been dealt with in the scientific and technical subcommittee. The subcommittee discussed as part of its agenda from 2001 the issue of NEOS. But it was only in 2007 that established the working group. This working group was initially under the chairmanship of somebody from the UK, Richard Crowther, for some of those that you might know him. And in 2009, it passed to me. Now, the working group is an intergovernmental entity. It's how the subcommittee dealt with the issue. It's a more relaxed atmosphere, but it's still formal. And it's then governments working. The action team, as I mentioned, was actually then established by the committee since 2001. The composition of the action team has been in the category of experts. Even though those experts some of them come from governments, government representatives, that is from their embassies, the ministries of foreign affairs. Some come from space agencies, some come from regional centers, as in my case, and some come from NGOs, as was the case with Secure World Foundation, which was one of the strong sponsors for many of the activities that we have done. Now, the subcommittee received the report, the IAC report that Doreen just showed us there. We had the cover, there was a list of the members of the panel, and the recommendations that they made then came through the action team and given out to the scientific and technical subcommittee. The subcommittee then started discussing it primarily in a working group. In a working group, it means that the expressions that are made, whatever representatives of government say, do not get reflected in the report. The only thing that's reflected are the agreements. And this makes then government representatives more comfortable. They can ask, more direct questions or state more directly what they like or don't like about the issue that may be discussed. So if you remember the block figure that Doreen had in towards the end, it showed what was called at the time an MPOG, that was a Mission Planning Operation Group. This was one of the recommendations that ASC then made to the subcommittee. The subcommittee actually took that recommendation after we ran it through the action team and changed the name. Gave it a more accurate name from the point of view of space agencies, something that they felt comfortable with. So it became then the Space Mission Planning Advisory Group. And they wanted to have this word advisory because it meant that they were not being told what to do. This was the advice that was being given. And of course, since they are members of that, they will be putting things into the plans that they are willing to carry out. And what we have in that group is actually the big agencies. NASA and ESA have been driving the process, but we have had, I think, another 7 space agencies that are participating and discussing terms of reference, what they're going to be doing. This other group did not change. It's the wording changed, sorry. Now it's an International Asteroid Warning Network. The acronym did not change. It's the wording. And this is essentially those who look for the asteroids, and they are to make, to establish, there aren't any right now, criteria and thresholds for notification of a possible impact threat, which is important because nobody wants to create panic. So there has to be some kind of agreement on when our governments notify that something is coming towards their country. And it'll be this network that will establish those criteria. Now, most of the parts of the IAWN exist already. Now, this is the Minor Planet Center, and these are all the telescope around the world. They're doing the searching, and eventually it will be telescope. The foundation, B612 Foundation, is going to be putting up into space. These parts are not going to cost any extra money because they already exist and they're part of programs. Now there's another part. The network is supposed to establish linkage and communicate with those that are responsible for disaster management. Somebody has to tell the disaster management, if this hits, it's equivalent to an earthquake of magnitude 10, Richter scale 10. Because then they know what that means. They do not know what it means to say this is the equivalent of 10,000 Hiroshima bombs. That means nothing really to them. They just know it's a very big impact, but they have no way of working. So we need to have this ongoing. We're not going to set this up and put it in motion when we find that there is possible impact. We're going to set this up. We are setting this up, and these groups will start working immediately. They'll start looking at scenarios and so on. This I mentioned already. It's the MPOG in the previous one, and here it's called the SEM page. And I already mentioned they are working on their terms of reference, and we hope to conclude those at a meeting next January at Darmstadt again. We'll have that meeting in Europe. Possibly now in October we'll have a meeting with NASA to look at the establishment of the network, the I1, the IAWN. And there were two supporting recommendations that were made, which are very important. One is that these groups that are being established, the United Nations should recognize that they are going to be acting on behalf of the international community. And this is in case something goes wrong, that we don't have then liability issues on whoever tries to help. So the idea is we agree we're not going to let an asteroid hit city X, but then we collectively take the responsibility if something goes wrong. And the other is, since these entities don't exist, then right now it's only the action team that can bring together the people that will actually be establishing the network and the space group. And once this is established, this group will disappear. I lost a couple of slides. I'm sorry. I think this is a different version that I loaded. I was going to show how graphically how the action team works. So I'll just describe it. The action team is an expert group. The action team provides things to the scientific and technical subcommittee, and that's a consensus body. So when we reach agreement in the subcommittee, it's highly unlikely that COPUS will change it. And when COPUS reaches agreement and sends it to the General Assembly, it's highly unlikely that the General Assembly will change it. So these agreements that I mentioned, the recommendations that we have taken, will be taken up right now in October, will most likely be agreed with no changes, and the General Assembly will adopt it in December. So that by the time we start 2014, we will have the mandate to establish these groups, the recognition of all the governments that are members of the United Nations, not just the 76 or so, but all 192 governments will actually sign on to these recommendations. And the rest of the work is to make them happen. And thank you very much for the attention.
registered with ASC and the Mexican Ministry of Foreign Affairs and 1814, was that there should be real attention paid to the communications that the IAWN would give to the media and to the public. So what Secure World Foundation did was put together a workshop with a few scientists, science journalists, risk communication experts, and so forth, and of course the ASC and staff from Secure World Foundation. And basically, one of the findings that came out of this is that establishing a communication strategy requires work, it requires planning, and so forth, and the effective use of the mass communication tools, such as all of the lists you see here, television, internet, and so forth. It will also include educating government officials. They're the folks in each country who will have to make the decision for their own country, but very few government officials know much about the threat. We found that the IAWN should develop an effective plan for educating policymakers and other stakeholders. It also should develop a general education plan using all the kinds of resources possible, including things like planetariums, because those planetariums are a very effective source of detailed information about astronomy and including asteroids. And one of the interesting recommendations that came out of our workshop was that it might be a good idea to use broadcast meteorologists to help familiarize the public with NEOs that pass close to Earth. For example, one happened just about the same time as our workshop. In 2011, it's the YU-55. It's a close pass. And then another interesting thing that came out of it was that visuals are an ideal tool to convey the scale and, compare them to familiar objects. And so we had an artist in the workshop who gave us a little taste of that, taking a very fuzzy image of asteroid YU-55. He made some guesses that had been compared to the size of an aircraft carrier. I don't know how many people know how big an aircraft carrier is, but it's kind of interesting to have a look at that and see how it compares. And there's the asteroid sitting right above one. He added a shadow to make it more realistic, and then put some details in that were best guesses. And here it is. So this is one way to convey to the public, certainly things like size. One might think through what an artist could do to illustrate potential damage and so forth. Another thing that we discovered is that when we looked at this carefully, that there was no real communication strategy and protocol for disaster, worldwide disaster notification. But, we have experienced, if not worldwide ones, very wide regional warning, need for wide warning, such, and we have developed the tsunami network in Southeast Asia. So one of the things that was recommended was that the IAWN should make use of the existing networks and develop a clear international communication plan and chain of command. And again, all the public information tools possible. So the other recommendation we made was that the IAWN should use familiar analogs, metaphors, and visual imagery one of the interesting things that happened in the workshop, one of the scientists said, well, you know, there's this one chance in 25 of this happening. And one of the risk communications people stood up and said, well, I don't understand that. I think he was pushing it a little bit, because I'm sure he did understand it, but many people in the public do not understand it. How many people here, for example, really have a good grasp of what a 30% chance of rain means? I have to look out first to see whether I think that 30% is going to cover my geographical area or not, and whether I take my umbrella. So it's those kinds of things that we need to develop some interesting ways of thinking about. And here's some other images. The asteroid Steins with Uluru in Australia. Scott Hubbard already showed this image, but this here is an proposed image of the Tunguska asteroid, and of course Scott had the Chelyabinsk one in there as well. So the other thing that is really important is to have a dialogue with risk communications experts, people who know how to communicate risk, the levels of risk, and so forth. They've done a lot of work, a lot of research on these issues over the past few decades, and they can help out a lot. And we also pointed out again that using the language of math and science don't work so well in communicating risk to the general public. So. And then, of course, different kinds of, different levels of risk require different types of communication, and we made some specific suggestions about that. And then it so happened that in November 2011, we had just had the UR's spacecraft fall back to Earth. That made a lot of, there was a lot of interest in that in the media. October, the Rosat from ESA, and then, of course, Phobos Grunt, the failed Russian Space Agency mission, fell back to Earth in January 2012. And they all got a lot of interest from the media. And so we can learn something from how the media dealt with it, what were the misconceptions, what were the mistakes in the press, and things like that, and try to understand that. And the final word here in this part of it is do expect media distortions and find a way to counter them with continuous updates about the information. And then finally, several of the people in our workshop said, gee, we shouldn't focus all of our attention on the risk. There's some very interesting mysteries about asteroids that are scientific and interest the public, and they can intrigue as well as threaten. So that's that was the final sort of suggestion out of this workshop, that we pay attention to those kinds of things and use the interest in asteroids to educate the public. So thank you very much.
So, here you see this year's logo of the Space Generation Congress. It is now in its 12th year. It is the SJC's premier annual event, and it is held in conjunction with the IAC. And each year about 100 students and young professionals come from all over the world to come together for 3 intense days to network, to learn and work on space topics. During each SGC we have several working groups. This year we had one on NEOS, and it focused on society. And we will hear from Lauren and Niels what the group discussed during the 3 days and what recommendations came out of their work.
Thank you for that great introduction. Saves me some time. We asked ourselves, how can the neo-threat information be delivered to the public in a responsible manner, in a truthful manner, in a manner that there isn't any panic? And for that we asked a number of main questions, like what does an effective communication plan of near-Earth asteroid threat actually look like? How can we set up an international education program? How can we identify communicators who are supported by help groups? And we also looked at where we could obtain reliable information. This is based on the report which Ray Williamson just presented by the Secure World Foundation. This project was also supported by the Secure World Foundation. Now, Lauren will present the first two questions and I will conclude again.
This is the situation we're talking about here. So you guys have all seen these images today. The first question we looked at is, what does an effective Neocommunication plan look like? So one of the ways we had to look at this was looking at it in terms of the temporal distance between an impact. So with regard to the long-term situation, maybe 20 years before an impact, we had talked about targeting the general public through awareness and education. The IAWN could provide educational materials and strategies. Like, for example, with the Russian situation, so much of the injuries came from people coming close to the windows. So we could advise people, don't go to the windows, and protect a lot of people that way. Governments could implement the IAWN material and recommendations. In the medium term, as we get closer to a predicted impact, we could target government decision makers for preparation and planning, and using contingency plans and proven methodologies that disaster management experts already use and are aware of in a language that they understand, which Ray mentioned earlier as well. And in the short term, perhaps in a couple of days, maybe a few hours, when we know this thing is about to hit, we could target both the general public and governments with really clear, simple, direct messages that describe the asteroid impact in a way that the public can really understand. So the Mercalli scale for earthquakes, for example, can explain to people how it affects themselves, how an impact would affect people, but also the structures and the things that they see every day in a way that they can get. What can we do as space gens? SJAC could provide educational material among young students and professionals, similar to the YGNSS pamphlet here that's translated into multiple languages, so we could create one of these for asteroids. SJAC could also employ available tools such as the Move an Asteroid contest that Massimo just presented earlier today, Name an Asteroid, again, a way to reach larger audiences and translating them into different languages. So the next question we looked at is, what does an education program look like? And we broke this down into different sectors of the public. When it comes to the general public, we could employ experts that could raise awareness through media, and traditional media and through social media. The International Space University has a journalist training program. We could do something quite similar to that. Providing factually correct content to television, film producers, advertisers. This is seen with JAXA, which has a television program called Zero that airs once a week. That's very technically accurate. The Science and Entertainment Exchange with the National Science Foundation in the US actually sends engineers to consult with television producers to make sure they have technically accurate information in their movies, such as Europa Report, that's one example. And Twitter campaigns, using social media to reach large masses of people at the same time. For people who maybe not watching television as much, or maybe not on Twitter, virtual forums and community town hall style meetings where people in the public can ask questions to real scientists and experts to allay some of their fears. And leveraging NGOs and their networks that already exist in regions that may not have, again, this sort of access to technology, such as the Red Cross or UNICEF. They already know how to go out and reach cultural divides and how to reach people that maybe would be difficult for us to reach here in the developed world. When it comes to policymakers, and this is another question that Ray brought up earlier, the reason that they care about this is because the general public cares, at least assuming we get it right with the general public before. So being able to connect the policy experts to accredited organizations, such as the ISU, who provide them with the factual information that they need. International groups could be providing options for responding to the neo threat and its possible consequences. And the NGOs could serve a really special purpose of bridging that gap between the policymakers and the public, because they're more connected to the public. They could then raise awareness to the policymakers. When it comes to students, another sector here is leveraging the existing science curriculum. So when students are in, science class learning about the solar system, they could also learn about the NEO threat. Supporting museums, planetariums, and science centers that are already out there, just providing them with information to, again, adding this to already existing formats that are out there for education. And for people who don't have access to planetariums and museums, using Skype and other virtual tools to connect with these students. And again, educational competitions, another way to really spread the word. And Niels will now come up and talk about how to identify these communicators.
Thank you. So, as a group, we recognize that every nation in itself has emergency planning boards. Every nation has its own culture. So, the best people to tackle this, to identify these communicators, are the national risk management people themselves. So we advise that national impact risk management is implemented within existing structures in nations such as FEMA, for example. Now, this will still remain an international disaster, so the international planning should be done by an impact disaster planning advisory group under the SMPAG, as talked about before. There also needs to be a central body for communications between nations and with nations. And it's also important that for the reaction, how nations react, that data on that should be shared among each other via the UN. If there is no immediate threat, we propose that these groups actually provide material for national outreach programs so that people can be educated on the NEO threat. If there is a threat on the short term, we advise that there is a national awareness campaign set up within every nation, since every nation knows which capabilities they have and how they can speak to their own population. Information on NEOs can be found in these sources. So GPL has a great source with data from the Minor Planet Center. ESA has a great source, and on this subject, of course, look at documents of the General Assembly of the United Nations. Now, I would like to thank you. My team would also like to thank you. These are people from 10 nations who worked on this subject. We would also like to thank Dr. Simpson, Dr. Williamson, and Dr. Carnett for their support. And please remember, be aware of the danger from above.
Thank you, Niels and Lauren. Okay. We're a bit short on time, about 15 minutes left, unless they let us stay longer here. It seems that is an option. I would like to invite our 4 panelists up on the stage, so we have time for question and answers. And we will combine that with an interesting exercise that was done in April at the Planetary Defense Conference. The exercise was designed by Debbie Lewis in coordination with Lindley Johnson from NASA, and Bill Ayler, Paul Schroders, Don Yeomans, L.A. Lewis from FEMA. The exercise was designed to be realistic in regard to orbit mechanics, time frame, and information updates. So it's basically planetary defense in action. So you can see the process, or you can try to imagine what different actors would be doing. So since this was done for the first time and we had 200 experts there was quite an interesting experience. And Ray and Sergio and myself were there actually, so we can tell you a little bit around this, about this. So what I would like to ask you to keep in mind is that there were 10 groups where the participants were divided in, so pick your favorite, or you can jump between each update, but There were lots of discussions going on with each group as the updates about the asteroids came in. So now at any point in time, if you have questions to our panelists, please raise your hand. We should have a microphone somewhere. And we try to play this along as the exercise progresses. You can please take a seat and you feel free to ask questions about this. So we have an imaginary asteroid. I hope the microphones work there. It seems. So it was discovered in 2013. So if we assume we discover something today, the first estimates indicate it's a 200 to 300 meter diameter object. So it could cause quite some damage depending where it hits. And there is a small keyhole. That's a technical term. It's basically a region in space that if the asteroid flies by Earth in 2023 and it hits this keyhole, it will guarantee hit the Earth on its next approach, which is 5 years later. And at this point in time, the impact probability is 0.8%, which does not sound very much. But it's also not too little. So you could imagine the science community obviously wanting to have more information about this. I skip ahead to 2019 when we get the next observational data, and the impact probability has risen to 28%. It was confirmed the asteroid is 300 meters in diameter. And there are some predictions where the asteroid might hit. You see the red line? That is called a risk corridor. So according to present data, we cannot pinpoint it, but it will impact, well, with 28% probability, along this red line. You might notice none of the major spacefaring nations is directly concerned, but a lot of many other countries. So the question is 28% enough to start thinking about the deflection mission? Is it enough to get the UN involved? What do you tell the public? How do you tell it? So, and I invite our panelists to share their thoughts on at this point in time is 28%, what their thoughts are on this. Are there any volunteers? Or are there questions from the audience? We have a question already?
Okay, from the risk communication literature, we know that how do you plan an information campaign that has such a long lead time and has so much improbability or of knowing what the public will do in response?
Sergio.
Well, in some of the meetings, not necessarily in this one, that we had with communicators, media communicators, they were unanimous in that in this day and age, it is not possible to hide something of that magnitude, and that it's better to prepare a communication campaign than to have then many different stories. Part of the recommendations that they made was that there should be a clearinghouse that is trustworthy so that the media can actually go to someone with questions, for instance, like the one that you post right now, or many other questions. The ones who would have been notified before would have been the governments involved. If the risk is as high as 28%, then those countries that might be that are in the path of the risk corridor would have been notified, and they would be the ones responsible for notifying their own people. so that that doesn't come from outside. It's the government decides when, but the advice was prepare for it. The sooner the better, because somebody is going to find out and put it out on the internet, and then panic will take over.
Let me add to that there's also a need to say it again, and say it another time, again through the trusted source, because there will be, we've seen this happen time and time again, there will be, one, misinformation, there will be deliberate misinformation, and attempts by people wanting attention to miscommunicate and effectively attempt to cause panic. So there are some really serious issues in terms of thinking through the entire problem, and at 28%, it's a tough call at that point. And my guess is, in reality, most people will not pay a whole lot of attention at 28%. That's my guess. I mean, but it is necessary to have the information available so that people can refer to it, because they will hear about it if they're paying any attention at all to the news. And I will say that during this exercise, as you well know, there was a lot of confusion in the room about what do we do, how do we think about this, and so forth and so on. And actually, I think the following through with more of this exercise will be an interesting story for our audience.
Well, we don't have that much time to go into detail, but I can skip a few slides and go to the recommendations that came out of it. But I saw there was another question.
Maybe to broaden the discussion a little bit, there was a very interesting series of agreements that were made in Vienna about 2 weeks ago during the International Atomic Energy Agency meeting between Russia and the United States. And many of them are on nuclear technology development, but there was a very interesting agreement between the Russian Nuclear Agency and the U.S. Department of Energy, and this was on planetary defense. I don't know if people are aware of it. Los Alamos National Laboratory, which is a Department of Energy research and development laboratory, has been doing some studies and looking into perhaps nuclear technologies for deflection of asteroids. So this is a very interesting international agreement, a little bit outside the box. In other words, not just space agencies, but other kinds of organizations getting involved. Because I know NASA, the Russians have been before the Chelyabinsk incident, the Russians have proposed almost 2 years ago what they call a strategic defense of Earth, and have tried to get the United States interested, have talked to Charlie Bolden about it, and to get other countries interested. And I was wondering, if anybody was following this. I know there are no Russian speakers here, representing or can discuss what the government is doing, but I thought this was a very interesting initiative.
Anybody? I have not
actually.
So.
I make a comment. Different space agencies, they have their own program on space situational awareness. Space situational awareness, dealing with space debris, dealing with space weather, dealing with asteroids, and some other connected problems. Of course, if they started to develop a program, it was a little bit difficult to connect them and put them together to think, not only to think in the same way, maybe they think in the same way, but they try to use their own resources to solve the problems for their nations. Now, having this report of COPUOS on near-Earth objects, and the report will be adopted in October by the General Assembly. It's an important tool for nations to start to cooperate. It's a stimulating document to start to cooperate and to find common ways to solve the problem. This is my view now.
Yeah, I'd like to add one point from a slightly different perspective, which came out of the exercise that Alex and others are talking about. And I think it was a sort of an aha moment for some of the attendees, which is the collateral supply chain effect of any disaster. We saw that particularly with Fukushima. We had a nuclear power reactor tragedy in Japan. And of course there was a lot of local damage, a lot of people injured, the plants are being shut down. But what happened in addition was that the supply chain of automobiles, parts for Toyota, rippled through the entire world. It is estimated that the gross domestic product of the entire world went down 0.1% because of what happened to that one reactor complex in Japan. So the world is now so interconnected, and there are so many different nodes that you're unaware of, that a tragedy in one place doesn't stay there. It ripples throughout the entire world, both financially as well as from a human scale problem. And so I think that we need to think about this globally. I mean, I know that's a trite phrase, but we need to, act locally, but think globally when we plan for what might be the effect of a cataclysm in one place.
Are there any other questions? Sergio.
I actually do have a question, and that is, would you have the reference to this agreement that was just, I guess, adopted in the Atomic Energy Agency? I understand it was just this last month?
I think it was September 17th or 19th.
Oh,
very
so
recent.
this month?
Yeah, maybe 2 weeks ago.
I'm not aware of that agreement, and the nuclear option is an option, and exploding a nuclear device. Should we have very little warning if we have a few months, 6 months, 8 months, and there is no time to have a kinetic impactor, then it could be that the only thing that would deflect an incoming asteroid, or if it's very large, might be a nuclear device. And it could be that this is in preparation to recognize that no, we do not place weapons in outer space, and nobody wants a nuclear explosion in outer space or the atmosphere, but when the consequences of not doing it would be catastrophic, it may be that this is preparatory. And I would love to see it before we have our next meeting of the space agencies.
Well, it was at the Vienna meeting of the International Atomic Energy Agency.
In September, then I can get online and I will look for it. Thank you very much.
You're welcome.
Okay, I'm into risk communication, and I think about all the what-ifs and the worst-case scenarios. So one of them also is, what happens if the scientists and other experts recommend a mission, whether nuclear or otherwise, and then something goes wrong? Have there been recommendations to get legal experts thinking about liability for those that are making those risk decisions, just as in Italy, there were problems when with earthquake predictions, and there actually were scientists that were found guilty by giving communications that said it was okay to go back into their homes, and then that night a large earthquake hit. So people are suing the scientists who made the decision. So has anyone within Secure World Foundation or this whole group started to think about those aspects of the liability?
I can speak for SWF in this case, and no, we have not tackled that issue, but we recognize it as an important issue as well. There are a number of issues around this whole thing that need to be explored in more detail. Just need world enough and time.
Yeah, one thing that I didn't emphasize in the interest of time about the Sentinel mission is the actual observing cadence. Okay, the way the observing scheme is structured is to be able to give you not only a detection, but a trajectory that is good for 50